Alright, welcome back. So this is the electronic load. I'm trying to finish it up here. It's been sitting on the back burner for too long, and I want to get this finished because I actually have good uses for this. I could have used this last summer. I got a solar panel I wanted to test the output on. Power supply modifications and repairs. It's really cool. I think I can use this. So what I've done since last time is I've ordered a second fan controller, and I'll install it on the other side here. As you can see, I've done the wiring, and what kind of mess have I created here. 16 MOSFET transistors all wired in. Took me all day, but you know, I did it. And it's not pretty, but who cares? It's going to be covered up as long as it works. I know this isn't the most efficient design, but I wanted to have a design where the heat sinks were mounted this way, the airflow, and I suppose I could have done it. With one fan on one side, and then had both heat sinks stacked behind it, and it would have drawn air through, and it would have been just as good. But you know me. I get carried away, and I don't always see the obvious or the simplest way of doing things, so I just go ahead and do it. So I got dual fans, dual heat sinks. These two banks will be controlled by this fan controller. These two banks will be controlled by this fan controller. I got the power supply mounted. I'm still not sure if this power supply will work. It's yet to be determined. Once I power it up, these fans draw incredible amount of current, like 1 amp, 1.2 amps each. That's when they're running full torque. And if these fan controllers are pulse width modulated, you know, we'll get less than that, but we'll see how this works. We might have to scrap these fans and put in some cheap Chinese computer fans. But for right now, let's try and get this going. Lots of stuff here to do. I got temperature sensors to wire on. I got a wire in a second fan controller. All the power wiring has not been, this is what all this is. This is all power wires, and nothing's connected power wise. And then I still have the power switch. You can see it down here, this power switch. I got a blue LED installed in it, so I need to get a dropping resistor for that LED and wire that in. And then we can turn this thing on and start testing it. Oh, another thing I need to do, I forgot to do actually. It's going to be hard now. Let me see if I can find a pointer. These B and C connectors here I installed for scoping the inputs. I still need to get a capacitor and jumper that over to the positive side. So I'll have to install four capacitors for those B and C connectors. So I got a little bit of work here. Probably the first thing is I'll drill and mount this fan controller, and start wiring up power, and do the grounds first, and then I'll work on to the positive, the B+. But yeah, looks like it's coming along. I know it's not what everybody thought it should be or what it could be, but if it's going to work for me, it's going to work. So I'm mostly concerned about this power supply, if it's got enough jam to power the fans. And let's see here. I got another power supply here on standby just in case this one doesn't work. This is a 24 volt. I don't know if you can read this. Where is it? On the output here, it's got 5 volts, ground, 24 volts. So this is out of an old fax machine, and it's a very nicely built supply. It's fused. It's got you know, all the EFI protection on the input. It's got a KA7552 controller chip, and then some kind of MOSFET on there. I don't know. It's a 10 amp MOSFET. And it's all regulated. But I took out the 5-volt regulator because I'm not going to use the 5 volts. I'm just going to use the high voltage outlet, and then if I have to, I'll go in here and tweak the opto isolator and stuff, because it's got a TL431 chip hidden in there. Yeah, we can fudge this to make it work. It's got a nice fat cap on there. It's a 220 microfarad Rubicon, so like it's a quality power supply. But we just need to adapt it to our needs. Okay, that's a possibility if we need it, but we'll try going with this one first, and we'll see how that goes. Alright, so first I gotta drill some holes and mount this fan controller. Alright, so I spent the last couple hours wiring in the power supply. Here, I'll show you what I did. I'll tip this up. I mounted the fan controller there. I put a terminal block here for the 12 volt supply. Everything can tie into there. I wired in these 4 boards into the terminal strip, and I wired in the LED lamp. So I think we're ready to try this and see if it's working at this stage. I haven't done anything with the fans yet. I still have to figure out these fans. I got 3 wires here on the fan, and I got 4 wires on the controller. One of the, on the controller you got plus minus, and then you have your PWM, which is your pulse width modulation, and then you have an S, which is your sense. And I'm wondering if I can just run it with the plus minus and the PWM without the sense. I'll get to that point, but let's try this out. I just plugged it in, and everything appears to be working. Yes, that's good. Nothing's weird here. Shut it off, takes a while to decay. I should put an ammeter in there, see how much current this is drawing. I think I measured 30 milliamps for each one. So it should be well within tolerance of what that supply can give. Alright, so onto the fans. Okay, we got an initial test here. I got it powered up with my 24 volt 1 amp bench supply, which is set to 9.6 volts right now. And I got the current maxed out on the supply, so we can turn this up and start drawing current from it. And we're at 200 milliamps. I like it. I like how we got the current and the watts at the same time. You can see the voltage drop a little bit because we're putting current on these wires, and it's quite natural for that to happen. The more current we draw, the more sag we're going to get in our voltage. Refresh rate's not very good though. You get it once every second. Be nice if that was a faster refresh rate. And I'm sure it looks all flickery in the camera, but it looks fine in real life. Okay, let's just keep going here. Keep putting the current to this power supply. We're drawing 8.5 watts, 9 watts. We're at 1 amp. Gonna keep going with this. And that's where it all falls to crap. You got 1.1 amps, and the power supply no longer supplies any current. So let's turn up the voltage on this power supply to 24. Let's see what it does actually. I think it goes up to 30. Okay, what are we at? 26.6. Okay, let's try this again. This is good because you can load a power supply down and then you can test and see how it handles the cooling. What happened there? We jumped to 1.1 amps. Seems like 1.1 amps is the limit of that power supply. After that it shuts down. Yeah, see, the voltage is starting to drop. And it crashes right here, 1.12. So yeah, it's working. Let's try another power supply. Okay, here's my switching power supply. It is 30 volts at 5 amps. And what have we got here? 31 point something. Let's start putting the beans to this one. I don't have the fans hooked up yet at all. I'm still working on that. I just wanted to do a test here. These pots are really cheap. This one's all crunchy. So we're drawing 45, 50 watts. Power supply says 1.62 amps and we got 1.62 amps, pretty close. Oh, it shut down. It doesn't want to release the load. I think I blew up my power supply. It says 0 volts right now. Poor thing's dead. Shut it off. Turn it back on. No, it's not working. Cheap Chinese garbage. Looks like we're going to be doing a repair on that one. So yeah, it's working. Good for burning up power supplies, especially the Chinese ones. Oh, that didn't get hot, did it? No, it's not even warm. Okay. Well, let's finish. What is that reading? It's nothing there. How could it be drawing current? Okay, let's finish up the fan wiring. Alright, so I got one fan wired in. The power on this side. I have the temperature sensor. And I have the alarm, the little beeper. And I got the 3 wires for the fan soldered onto the board. I had to remove the connector to make room for it because I don't have a Molex connector like that. And everything's connected. Should be good for a test. Okay, so let's turn on the isolation. And turn on the unit. We've got full power. We don't want it going full. Let's see here. We got some settings on this. You got TP1, TP2. Should be off for 35 to 45 degrees Celsius. And positive, negative. I got the pulse width modulation in positive. Like, I got it all wired in right. It's just not. I want to turn this one here to that. Let's try it. Sure moves a lot of air. Yeah, 11 volts. This is 11 volts regulated, so it'll work. I just don't know why it is not sensing. Let's take this off. Alright, guess it's not going to work. Might have to put my thinking cap on. I'm going to hook up this one here. Maybe this is defective, who knows? Could be, could be. And we'll try this one out and see if this one works. I'll wire this one in next. Alright, let's try this again. Maybe the battery won't go dead on me. So what I did is I went to the NIDEC website and I was looking for more information. I was actually looking for a data sheet for these fans to make sure I'm using them right in the right application. Didn't find anything, but I did find this, and this is interesting. It has the lead wires. Red is your positive, black is ground, yellow is your signal wire, and blue is your control wire. Well, these fans don't have blue wires, they just have yellow, black, and red. So it got me thinking, maybe there's a way to go internally and find that blue wire or pad anyway. So what I did is I took the C-clip out, took the cover off the bearing, took the C-clip out, removed the rotate. What is it, rotator? Remove the rotor with the bearing still attached to it. Doesn't want to come out now. And these are true ball bearing fans. They're not Chinese garbage. These are really high quality fans. So I got looking at this, and you can see the red wire, the black wire, and the yellow wire, and there's a space in between here where there's no wire. So it got me wondering, maybe I could add a wire in there. So I looked behind here, and you can barely see in, but what I did is I took my nippers and I opened this up a little bit. And you can see there's 4 pads in there. I don't know if you won't be able to see it on the camera, I doubt it. But there is a pad for the positive, negative, then there's a blank pad, and then the yellow is connected to the outside pad. So I'm going to take that wire and move it over to the other pad, and I'm going to see if this fan can be speed controlled. So let's do that right now. Just want to get these wires out of the way. Pull them out of the way here, and then they're out of my way. Okay, let's try this. This might get ugly, but we're going to do it anyway. I'm going to heat up my new iron because it's got a small tip. And why isn't it plugged in? Stand by, I gotta plug my iron in. Alright, so here's the yellow wire. And I'm gonna just unsolder this yellow wire. Well, that was easier than I thought. Okay, well, let's attach it to the other pad. It's just hard to see anything in here. Is it good? Yeah, it's good. Okay, I think we're gonna be good. Pull these wires back up. So. So if this works, I'll replace this fan with one of the other ones inside the cabinet, and then I'll modify one of the other fans in the cabinet. Okay, so we got our 3 wires. I just want to make sure there's no shorts here. I can't really see. Yeah, it's good. Okay, so let's put this back together. Got nothing that came. Usually when I put stuff down on my bench, it picks up all kinds of garbage from the I'll push the bearing out. All right, got a little C-clip here. Gonna have to bend it back. That should be good. It wasn't easy digging this thing out. It was pretty, it's just a little wire clip. I need a couple screwdrivers to snap this in place. You just don't want it flying across the room, and then we're done. We're going to look for another fan if we find if the C-clip's gone. Yeah, you know what? This is not. I'm pushing against that spring. I need something to rest this on. Maybe this? It's on there. Okay. Sticky cover. I'm going to get some hot glue and make sure this does not come off. Although it might stay on there. But I think we're ready to test this. Let's hook it up and try it out. Okay, so I got this wired in, this fan, and I hope I got it right. So let's test it. I'm going to put some power to it. I guess I got to turn the power supply on first. Okay. Holy smokes. No, it's not going to go. Maybe we need that fourth wire. Sense wire, maybe? I can add in a sense wire. Let's do that. Okay, so I just lost the circlip, the C-clip on this. It went flying across the room, so oh well. We're down a fan. But in the name of science, I think we need to open this fan up and take a good look at the printed circuit board and determine what we're going to do with it. I went back to my stash and looked, and I have another fan here, same size, same physical size. This is from Delta Electronics. This one is 1.8 amps though. It doesn't say its speed or anything. I should look this part number up and see if there's a data sheet for this. But this is a 4-wire fan. Even though the wires are short, I'd have to extend them, but let's see what we can do with this one first. Let's have a look inside. I'm kind of curious what we're going to do with this. Okay, let's clean this up. And throw this away. Okay, let's have a look at this thing. Yeah, I don't want to destroy the PC board. There we go. Well, there's our 4 connections. I'm not going to reverse engineer this thing. I'm just going to throw that in the scrap pile, I guess. Clean this up. Let's hook this fan up and see if it works with the controller. Alright, so I'm just looking over this sheet to make sure I didn't miss anything with the settings. And it's kind of hard to read with the Chinglish. First channel 20% to 100% or 40% to 100% if you turn TFL on. Second channel and third channel 10% to 100%. Note, above range only for PWN range. The actual control effect will be vary depending on the fan. Temperature probe parameters. Thermostat temperature zone air. Depending on the generally 3 to 5%. Stall alarm. Function switch. Doesn't really tell me much here. TFL number 1, lowest on state. Okay, minimum. TP2, TP1. BF1, BF2, those are for the buzzer, I think. Stall alarms, okay. Package includes speed controller, temperature probe, and a buzzle. What the hell's a buzzle? B-U-Z-Z-E-L-E. Okay, what's this? What? Okay, so I wired up this 4-wire fan to the controller. Pulse width modulation, the blue is the speed sense, and then you got your plus minus. And I turned it on, and the fan initially kicks, but then it stalls. So here I go. So the fan spins for half a second, then it stops, and then it does absolutely nothing. If I heat the thermistor up with 100 degrees C, it does nothing. I'll show you on the scope what signal I'm getting out of the controller. So there's the output signal from the controller. That's my pulse width modulation. It's that's 200 millivolts per division. So that signal is 500 millivolts peak to peak, which I believe is a problem. Here, and it's working too. I'll show you. I'll heat up the thermistor, and we'll see how that changes. So here we go. The duty cycle changes, and then it goes full on. If I heat it up some more, it stays full on, and then when it cools off, it goes back into pulse width modulation mode, and you can see the width changing there as it cools off. Everything's working. Alright, so I've been fighting with these fans to get them to work in pulse width modulation mode, and connecting them directly to the Chinese fan controller, they just run at full speed, and I couldn't figure out what the hell is going on here. So I tried different things. I tried maybe this outputs a 5-volt PWM signal, so I figured maybe the voltage wasn't high enough. But even though in the data sheets it says that the minimum signal we can get away with is 2.8 volts, and the maximum is 20 volts. So we're within that range, is 5 volts, and I couldn't figure what the hell's going on here. Why wouldn't it run? So then I got thinking maybe it needed a little bit of a buffer, so I put a MOSFET in the circuit to buffer it. No, it wouldn't work. Tried a few different things. I even tried swapping the yellow and blue wires, because here, this is misleading. Black wire is negative, red wire is positive. Blue wire is your frequency, which is should be your speed feedback. Yellow wire is your speed control, which is your PWM signal. So this yellow wire should be the one that's triggering the speed, but it wasn't. So what I did is I got frustrated. I removed this, threw it aside, started trying to figure out what's going on with this fan. So what I did is I got my signal generator hooked up, and right now I'm giving it a 5-volt square wave, and I can vary the duty cycle on it. And I tried it on this wire, nothing. And then I switched it back to this, actually it's a green wire, but I spliced in a blue wire just to keep it. And I put it through a 1K resistor, and I'm feeding it a 89.9% duty cycle, and the fan's running. And if I'll show you here what happens when I turn up the duty cycle. Just let me move the camera here first. Alright, so I'm feeding it a an 89.9% duty cycle, which means it's on 90% of the time, and the fan is stalled and not running. Now watch what happens when I change this duty cycle. The fan kicks on and starts spinning. Full speed. Now to me that's 0% duty cycle. That's not 100%. There's 10%, 20, 30, 40, 50, and so on. So it's working, but the duty cycle that it needs to have it run is inverted from what I'm generating on this little fan controller board. So I have a choice: scrap these fans and try some other fan, or build a little inverter circuit that's going to flip the 5-volt cycle or 5-volt signal upside down and invert the duty cycle on it, which I really don't want to do. This is starting to become a real pain in the butt, but it does work at 5 volts, and right now it's spinning at low speed. It's got 90% duty cycle, and it's running at a really slow speed. Like I said, I got full control over the motor with varying duty cycle. So let me put my thinking cap on and figure this one out some more. Alright, so I think I got this figured out. I breadboarded a little MOSFET inverter circuit, and it's basically exactly what it says in the data sheet here. There's a little diagram with a MOSFET and four resistors, and that inverts the signal for what the fan needs. So it's working now. I'll give you a little demonstration, and happy Valentine's Day, by the way. So let's have a look at this. Okay, so I got it turned on, and right now we're flatlining with no signal. Let's start turning up the duty cycle, and it doesn't go full power, but it does a pretty good job. At 10% it does nothing. 20% it kicks in and starts. And right there is full, which isn't, it's probably about 1/3 of what the fan is capable of. I'm drawing 330 milliamps, and everything's good. So this is what I'm going to do. I'm going to put these fans in, and I'm going to wire it in with this MOSFET inverter, and call her done. And actually, no, what I'm going to do first is test it with the Chinese fan controller. Make sure it's all working. Okay, so this is what I've done. I built a little inverter circuit with the MOSFET, and I encapsulated it. I just did a little piece of perf board, and I just encapsulated it with heat shrink, and just so it's not going to be flopping around and shorting out. This is kind of a thing here, or you don't do your homework and put a lot of effort in for all for nothing. There's a pad here that I could have shorted out. It says PF on it, and if I read in the back, if you short circuit PF, what it does is it reverses the output signal. I guess it just inverts it for me, and yeah, it would have saved me all this hassle of building this little circuit and stuff, but whatever, it's a learning experience, and I know how to do it now. So I know, I've never worked with fans before. You know, I've turned them on and stuff and had them spin full speed, but I've never done this speed control nonsense. So here's a test. Let's try it out. The fan's on and it's running at low speed. You can barely hear it, and it's not moving much air, but it is moving air. Let's put some heat to this thermocouple. This is 100 degrees Celsius. And then it comes on full speed until it cools down, and then it goes back to its sleepy state. So I'm going to install this. It's working. I'm going to look on the other board and see if it has that jumper for inverting the output. It's a little bit different board than this one. Another thing I might do is I might up the temperature. Instead of going 35 to 45 degrees Celsius, I'm going to jump it up to 40 to 55, just to make sure that fan doesn't come on prematurely. BF1, alarm for fan 1. BF1. So if we stall this fan, it should beep. That's if I have the the signal, return signal proper. Okay, it's stalled out. The fan will attempt to restart after it times out. I don't know what the timeout is, maybe it's 10-15 seconds. The alarm's not working, so I really don't care about the alarm. If I'm pumping in that much heat that makes the alarms go off, I got a problem. So I got to turn on TP1. TP1 is this one. Hang on, let's do this again. Let's get rid of this power and reset the processor. I'm going to install a fan. Fan's running. I don't know what that, I know I gotta play around with it. TP1. Okay. It should take a little bit higher temperature now. Yeah. Okay. I still don't know what these two potentiometers do. I'm just going to leave them set to midpoint. I really don't know. But anyways, let's put this aside, and then we'll work on the other one, and then we'll get them installed. Alright, here we are again. We've got the two fans installed. The two fan controllers installed. Temperature sensors are here. Just going to do one last test before we close it up. Well, I still need to mount the temperature sensors on the heatsink with some silicone or something just to thermally bond it. Okay, it's turning on. We've got two fans going on low speed. Let's heat this one up. Try this one. Working good. I think everything's done and just needs to be buttoned up. Mount those two temperature sensors and button it up. Alright, just closed it up, put the screws in. I made a bottom panel out of just a chunk of scrap aluminum plate. It had a cool sticker on it, so I had to use it. But it's all finished. It just needs to be calibrated. I need to calibrate all the voltmeters, ammeters, and then give it a test drive, but I think it's gonna be okay. Not much care for these cheesy knobs and pots that they supplied with the electronic load kits. They're kind of garbage, but whatever. The amount of use this thing's gonna get, it will probably last me a lifetime. So yeah, everything's, plug it in, try it out. The thing I like about it is on the back, there's no controls or anything. It's because once I put it in its place, I don't want to be pulling it out to change a fuse or maintaining it in any way. All the controls are on the front, and let's give it some beans. Try it out. Fans are quiet enough that it's not going to be a problem. Get some current on this thing. Just want to check this voltmeter. This one reads, yeah, it's pretty bang on. Pretty darn close. I'm not going to worry about a tenth of a volt, or this one's way out. Why is this reading funny? Okay, we're down. This channel's not working. Maybe I got a shorted MOSFET. It's drawing 4.7 amps at well, here it's 1.5 volts, but up there it's 3.6 volts, so getting a lot of drop in these wires and they're getting warm. So this channel's buggered. I'll have to open it up and fix it. I guess that's the problem with using MOSFETs. They could die at any time, but the other three channels are good. And let's try loading down this one. Was it at 4.7 volts or amps before? See how high we can take this. .5. Three amps. 4 amps. I'm just going to let this cook for a while. We're drawing 41 watts. I'm going to see if the fan kicks in, how long it takes to warm up. 40 watts on that big copper heatsink, and there is already a good draft going across that heatsink already. It might not even kick on. We'll just let that go for a while. So I can hear the fan starting to ramp up. I don't know if you can hear that. I'm still drawing about 43 watts. Fan slowly starting to come up. A tiny little bit of heat coming out the back. I wonder, let's increase the voltage. That's the maximum voltage. .55 watts. Getting some good flow now. So it's doing exactly what I want it to do, which is great. You can barely feel heat out the back. I drilled a few holes in the sides here just as a intake. The air's got to get in somehow. And there's not too many spots on this chassis where the air can get in. Take it up a little higher. $60 watts. Okay, shutting it down. Shouldn't take long to cool off. There we go. It's working pretty good. I like that. Goes back down to idle. Okay, excellent. Time to put this in use. That's about it for this project. It's working. I still have to do a repair on this channel. No big deal. I should probably pick up some spare MOSFETs. If you're going to start popping MOSFETs like popcorn, you're going to need some extras. So, you know, get into our destructive testing mode. Alright, that's excellent. Now we can put this on the bench and put it into use, and we can move on to our next project, which I have a few ideas for. I got a number of ideas for projects. I don't know which one to start first. Maybe should ask your opinion. Just hang on, let me get rid of this. Alright, I got three here. Three that I'm itching to get at. One of them is a Transistor Radio Kit. It's one of these Chinese, you've probably seen them on the other channels. People have done these. You've got pretty much no instructions except for a schematic, parts placement diagram maybe, some other indicators of what you're supposed to do, maybe a parts list and some Chinese text which I cannot read. But this is like a time-wasting kit where you can assemble it, put it together. The speaker looks like it's seen some damage here. It's been damaged, but whatever. Slap this together, align it, and we can do that. I'm kind of itching to do this one, a build. I'm kind of curious on how it turns out. Another one I have that's ready to go, and I would need to put it into some kind of a box or chassis or something. This is a transistor curve tracer kit, and you use it with your scope, and you can do curve tracing on transistors. This one I've been sitting on for quite a few months. I bought this a hell of a long time ago, back last summer in 2020, and I kept emailing this guy here at tiekits.com. I says, please send me the paper, because it doesn't come with any instructions or anything. Please send me the documentation so I can get started with it. I sent him like 3 emails and waited months and months. And then finally, back in January this year, I emailed him again just as a last-ditch attempt, and he finally responded. So I wasn't impressed with that, but I'd like to assemble this kit. Just so we can do some curve tracing on transistors, do some matching if that's ever needed. But this one here is kind of interesting. This one is something I need to get on. It is from Motulus. This is a broadcast multiplexer for stereo encoding. Produce a stereo signal. Doesn't come with anything. It just came as a blank board. But he does have a website up, and he's got all his information on the website. There is a PIC chip on here. Where is it? And it's a PIC 18F1220. I got the chips already from DigiKey. I just need to program them and assemble this. This will produce a stereo output signal, a multiplex stereo output signal that I can feed into my signal generator, because my signal generator right now doesn't have, it has modulation, AM/FM modulation, but it doesn't have any way to generate a stereo signal. So that is going to be teamed up with this. This is another kit that I'm going to build together and enclose them in the same, put them in the same enclosure as one piece of gear. This is a digital DDS signal generator, so I can generate my own tones, 400 hertz, 1000 hertz, whatever I want it, whatever tone I want to generate. It's digitally, it's got a digital display. I can have it, so I can just set it up and feed tones to this board. And I also want to be able to feed it, set it up so I can feed audio signals in left and right channel. I want to set it up so it's all in one unit with its own power supply and enclosed. We've got B and C connectors on the outputs here. We've got a pilot, RDS, and multiplex signals coming out. So yeah, I'm looking forward to doing this one. So maybe give me your feedback, which one you'd like to see done first. All right, so that's it for this build. I know I didn't do a lot of things right, but I think in the end result was good. I think I learned a few things along the way. Definitely did learn a few things. That's the reason we want to build things like this. So all right, let me know in the comments what you guys think. You want to see more builds or not? And if you do, which one would you be interested in seeing? All right, thanks for watching, and take care.